Hello everyone, welcome back to our YouTube channel AgriAddict. This is our lecture series for IBPS AFO mains exam and also useful for other agriculture exams. In this session, we'll be dealing with another important topic of agriculture engineering, that is with respect to the fundamentals of farm machinery. Before that, let me introduce myself. I am your mentor Pavan Kumar. I have completed my UG from US Raichur and currently pursuing my masters in plant pathology from UHS Shumiga. As I told, today we'll be dealing with the fundamentals of farm machinery. We will be starting with the farm power. When I say farm power, it is with respect to the kind of works we do, that is the tractive work or the stationary work. Here, referring to the tractive work, here the works which are doing along with the motion will be grouping under the tractive work, and the works which are doing stationary means at one particular point of place will be grouped under stationary work. Looking into the example for a tractive work such as seedbed preparation, where tractor will be in the motion, and for the cultivation of process as well as for the harvesting process as well for the transportation, that will be in a motion, so it will be grouped under tractive work. And with respect to the stationary work such as the feed grinding, crushing, winnowing, lifting of water from the well, these will be under the stationary work. I think now you are clear with the what are the tractive works and the stationary works. And next, talking about the different sources of power for all these kind of operations, it will be majorly from the human power, animal power, and the mechanical power. That will be including our oil engines and the tractors, and electric power and the renewable energy. And under the renewable energy, it will be our solar energy, biogas, as well as the biomass. And now, first talking about the human power. First, to note here the how much energy that normally human will be having, it is around 0.1 HP. It will be on an average that tendency of a person to work. And the major advantage of human beings are they are available throughout the any seasons. There is no restriction. But the main disadvantages is their low efficiency, and some of the climatic conditions will limit their ability to work, because in rainy season humans may not work to their full extent how much they are working in the normal days. This will be the problem, but they can do all kind of works, and there will be no limitation for the human work. Means they can operate the small tools as well as they can operate the major tools with their skills. And next, moving on to the mechanical power. Mechanical power, it is available through the tractors, power tillers, and the oil engines. Here, oil engine will be highly effective in order to convert the fuel into the useful work. For exam point of view, what we need to notice what the efficiency of different engines. That is, for diesel engine, it is around 32 to 38%. Okay. Next, for the petrol engine, if you look, it is somewhat different. For the petrol engine, it is around 25 to 32%. It is with respect to the petrol engine. And next, in India, all around nearly 1 million tractors of 25 HP are in use for various agriculture operations. It may be for pumping water, for the flour mills, or for the cotton gins or the sugarcane crushers, etc. And as I told, the advantage is efficiency is high, and this particular mechanical power is not affected by the weather, and you can not run at the stretch, because sometimes even it will get tired due to heating of the machines and all. And the other disadvantages is the initial investment may be high for purchasing the equipments, and even you need to invest for the repair and maintenance of this particular equipments. And along with these things, some of the technical knowledge is also necessary to run the mechanical power. And next, talking about the animal power. Here, on an average, the power developed by the average pair of bullocks is around 1 HP. This you should make a note. Okay. And it is estimated that nearly 80% of the total draft power that is used in the agriculture throughout the world is still being produced by the animals. This encases that how much the animal power is important for the agriculture. Nearly India is having 22.68 crore cattle population. With this, it is mentioning the highest animal power in the world. And looking into the advantages, they are easily available, and you can use these animal power for all types of works, and investment is also less, and it produces the manure to the field as well as fuel to the farmers, and it also live on the farm produce, means no other extra input you have to give for the animals. And disadvantage is not very efficient, because like humans, they even have some kind of limitations like climate conditions, health upsets, so even they are not efficient. And even they depends upon the season weather for their efficiency, and even they cannot work at stretch like humans, because even they get tired, and even there is need for maintenance of these particular animals as well, and very slow in doing work as like humans. And if there is some unhygiene conditions around the animals, sometimes their efficiency may be reduced. And next energy is renewable energy. It is freely available one. And biogas, solar energy, wind energy, they are the examples for the renewable energy. And these energies are inexhaustible in nature. Okay, but the thing is, the speed what the wind speed that we are getting, it is very important. That is, in order to lift the water, the minimum speed of the wind velocity should be more than 32 km per hour. This is the minimum, more than 32 km per hour. And the average capacity of the windmill, should be about 0.5 HP. This you should make a note. It will be asked in exams. What is the average capacity of the windmill would be? How much? Minimum how much means it is 0.5 HP. And in general, it is the cheapest source available in the India. And next, looking at the electric power, it may be the costliest one, but thing is, it is cleanest source, means after using the electric power there are no other dangerous byproducts is obtained, but the maintenance is very high in this case electric, because electric shocks and all will be there, and good technical knowledge should be needed in while handling the electric power. And by using the electric power, you can perform all the major activities like pumping water, dairy industry, cold storage and product processing, what will be the in respect to agriculture sector. You can manage all these works efficiently. Okay, and its maintenance and operation needs less attention and care, but handling and the technical knowledge that is required for this maintenance should be high. And in general, on an average, about 1/10 of the total electric power generated in India is consumed for the farm work. If it is asked how much part of the generated electricity is used for the farm work, means it is 1/10 of the total production of electricity is used for the farm power. That is approximately 4,600 megawatt. It is being used. And next, looking into the heat engine. Heat engine is nothing but is a machine that is used for converting the heat that is developed by the burning of fuel into useful work. And under the heat engines, we have two types, that is external combustion engines and the internal combustion engines. And again, in the internal engines, we'll have two types, that is petrol engine and the diesel engine. Now, first we'll look into what actually the external combustion engine is. Okay, basically external combustion engine, if you look in, the simple difference is in this engine, the fuel will be burnt outside the engine cylinder. Okay, whereas in the internal combustion engine, fuel will be burnt within the engine cylinder. It is a major difference between the external combustion engine and the internal combustion engine. As I told, in internal combustion engine, we have again two types, that is petrol engine and the diesel engine. Petrol engine is also called as carburetor type, and diesel engine is also called as compression ignition type. And why we call so, we'll be seeing in the next slides. And now first talking about the petrol engine. Petrol engine is an engine in which a liquid fuel is atomized, means it will be sprayed in like the form of particles. It is vaporized and it is mixed with air in appropriate ratio, and it will be sent into the engine cylinder for the suction stroke, and thereby later it will be ignited by the electric spark. And this is how the working of petrol engine takes place. Initially, the inlet valve will be opened so that the fresh air will enter, and again the fuel will be atomized and sprayed in the inside the cylinder. Once the piston moves up, what happens? The compression will take place of that particular air mixture, and the petrol will be mixed. And upon mixture, upon the pressure created by the piston for the compression stroke, that energy is not sufficient to ignite the fuel. So with the help of the spark plug, ignition of the fuel will take place, and later the next stroke, that is power stroke, and which is followed by the exhaust stroke will take place, and the energy that is liberated during the power stroke will be pushing the piston downwards, thereby rotating the crankshaft, and the energy that is generated in this crankshaft, means that is the mechanical energy, will be converted into rotational energy, and then that makes the vehicle to move. This is in brief that what I have explained, how the petrol engine will be working. Inlet valve will be there the fuel and air will enter, and later that inlet valve will get closed, and burning of that particular fuel with the help of spark plug will take place, because the compression pressure that is created by the piston is not sufficient to ignite the fuel. So spark plug is taken help here. Whereas in case of diesel engine, this spark plug is not necessary. We will know that why actually spark plug is not necessary in the diesel engine in the next slide. I think now this is clear. And next, talking about the diesel engine, as I told here, the spark plug necessary is not at all present, because when the piston is compressing the fuel mixture, that energy itself sufficient to ignite the fuel in case of diesel engine, but in case of petrol engine it was not the case, because the compression pressure that is present in the petrol engine was not that sufficient to ignite the fuel. So there the spark plug help was taken, whereas here it is not taken. So it is the major difference between the diesel engine and the petrol engine. And next, looking into the difference between the petrol engine and the diesel engine, the differences should be very important, because in exam most of the time options will be based on these major differences itself. In case of petrol engine, it follows the Otto cycle. Otto cycle is nothing but a kind of thermodynamic principles that are related to the petrol engine, and diesel cycle nothing but these are the other set of thermodynamic principles related to the diesel engine working. Here air and petrol are mixed into in the carburetor, means directly it is not entered through the engine itself. Before entering into the engine, in the carburetor, the petrol and air get mixed and enter the cylinder. And whereas in diesel engine, it is not the case, directly it will be entered. Here ignition is by the electric spark as I mentioned, and here it is not the case, just by the heat of the compression. Here lower compression ratio, and here it is higher compression ratio, and here less power output, here more power output. It contains spark plug and it does not contains any spark plug, just it contains a fuel injector. Here high volatile fuel, means the combustion will be complete in this case, and here fuel combustion will be little bit incomplete. And petrol engines are used in the light vehicles like our motorcycles, and here heavy duty vehicles like heavy trolley load vehicles will be used. In case of for heavy vehicles, this diesel engines is used, and the torque generated in the petrol engine is less compared to the diesel engine, and the maintenance cost is less in case of petrol engine and it is more in the diesel engine. And other important is to note down their thermal efficiency. Thermal efficiency of the petrol engine is less compared to the diesel engines, it is around 40%. They are very speed, that is mileage they give more petrol engines than the diesel engines, that is high speed engines, and these are called as low speed engines. Okay, and here the starting of the petrol engine is easy because they need less low compression ratio, because along with this spark plug will be there in order to start the engine. Whereas in case of diesel engine, their high compression ratio is present, because in order to ignite or in order to start the diesel engine, complete fuel has to be burnt alone here, because spark plug is not present in this case. So high compression ratio, so starting of the diesel engine is slightly difficult compared to petrol engine. And these are major differences. And one more thing I want to mention, the compression ratio, it is from 14:1 to 20:1 case of diesel engine, and it is 5:1 to 8:1 in case of petrol engine. And specific fuel consumption is about 0.2 kg per bhp in case of diesel engine per hour, and it is 0.29 kg per hour in case of petrol engines. And these are the two-stroke engine and the four-stroke engines. There is nothing to much to understand here. I will be telling you brief, you will be understand it very well. See, when the cycle means enter this what the four-stroke engine are: intake stroke, compression stroke, power stroke, exhaust stroke. When all these strokes are completing in the single revolution of the crankshaft, all these four are getting completed in the one revolution of the crankshaft, we said two-stroke engine, means 1 and 2. Okay, this particular 1 and 2, they will be completed in the all together is one stroke in case of two-stroke cycle. And power stroke and exhaust stroke, they will be acting at a time. This is 2, means this only 2 strokes. What are the 4 steps we are seeing? They will be occurring hand and hard in case of two-stroke engines. That is what we say called two-stroke cycle engines. Here only in the single revolution of the crankshaft, all these 4 are taking place in the 2 strokes. Okay, whereas in the 4-stroke engines, in the 2 revolutions of the crankshaft, all these 4 events are taking place. This is the thing you should understand. This is how it is 4 strokes, and this is the 2-stroke. And looking into the differences, I have mentioned you clearly what actually the difference is. Okay, here rather is inlet and outlet valve was present in 4-stroke engine, and it is inlet and outlet port in case of 2-stroke engine. It has 1 revolution of the crankshaft within 1 power stroke, and it has 2 revolution of crankshaft in the 1 power stroke. Here 2 in the 4-stroke engine, and it is 1 revolution. This is the major difference. You can note down the remaining things by pausing the video. There are nothing much to explain. And other thing is the thermal efficiency. If you look, okay, 2-stroke engine gives the lesser thermal efficiency than the 4-stroke engine, and 2-stroke engine is producing more noise, compared to the 4-stroke engine, and 2-stroke engines are less efficient and generate more smoke compared to the 4-stroke engines. They produce less smoke and they are more efficient than the 2-stroke engines. And now looking into the terminologies present in the engine. First is bore. Bore is nothing but the diameter of this particular engine cylinder. Okay, engine cylinder's diameter is known as bore. And what is stroke? It is a linear distance traveled by this particular piston. This is a piston, right? The linear distance traveled by the piston from the top dead center to the bottom dead center is called a stroke. And stroke bore ratio is nothing but it is a ratio. Okay, it is the ratio between the length of the stroke, okay, this and the diameter of the bore. The cylinder is called stroke bore ratio. In general, it varies from 1 to 1.45. Okay, in particular for tractor engine, and this is for about 1.25. And what is swept volume now? It is a piston displacement in general. Okay, it is A into L. And next, talking about the compression ratio, it is the ratio of volume of charge at the beginning of the compression stroke to that at the end of the compression stroke. That ratio what we get at the end of the compression stroke, how much it is there, and in the beginning how much it was there, that particular charge. That ratio of the total cylinder volume to the clearance volume will be given by compression ratio. This was already mentioned in the difference, that is 14:1 to 20:1 in case of diesel engine is the compression ratio of the diesel engines, and 4:1 into is to that 8:1 in case of carburetor engine. Carburetor engine is also another name of the petrol engine. So other names of the petrol engine also important for the exam. And what is power? It is nothing but it is a rate of doing work, and SI unit is watt. And HP is also another way of measuring the work done. And here 1 HP is equivalent to 75 kg per meter per second. Okay, and what is the dB HP and BMEP is nothing but first dBHP, it is the power of the tractor measured at the end of the drawbar. Okay, this power is required to pull the loads. And brake mean effective pressure means BMEP, it is the average pressure acting throughout the entire power strokes which are necessary to produce the BHP of the engine. Okay, I think now you are clear with these terminologies. If you did not understand, read again once after watching this video will be clear. And next, high HP, that is indicated horsepower. It is a total horsepower developed by all the cylinders, because sometimes single cylinder is not sufficient to provide necessary energy for the piston to move. So several cylinders will be connected. Okay, several cylinders will be there, all together will be helping in order to provide the energy for the piston to move. And the formulas are listed over here. Okay, for high HP for the 4-stroke engine and for the 2-stroke engines are given. And P is the mean effective pressure in kg per centimeter square. Okay, whatever what they are standing for I have mentioned. It's the length of the stroke. L, N is RPM of the engine, and A is the cross section of the piston. And now the point is, what is BHP and FHP? Brake horsepower is the horsepower which is developed by the engine, and which is available at the end of the crankshaft, and it is measured by the suitable dynamometer. Okay, BHP is nothing but it is a horsepower developed by the engine and which is available at the end of the crankshaft. It is measured by the suitable dynamometer. And what is FHP? That is frictional horsepower. It is the power required to run the engine at the given speed without producing any useful work. Means here no any useful work is being produced, but that is power required to run the engine. These are the formulas of FHP and IHP. Okay, indicated horsepower and the brake horsepower. The expansion is also important to note down. And thermal efficiency is nothing but it is the ratio of the horsepower output of the engine to the fuel horsepower. And mechanical efficiency, it is the ratio of the brake horsepower to the indicated horsepower. This formula simply you can note, that is BHP by HP into 100. And talking about the piston speed, it is the total length of the travel of the piston in a cylinder in 1 minute. What in 1 minute that particular speed of the piston is, that we say it as a piston speed. And BMEP and the BMEP for the 4-stroke engine and for the 2-stroke engine it is there, and it is calculated by the formula, that is brake horsepower into 75 into 60 divided by the ln into 2n by 2. And if you remove the 2, and it will be for the 2-stroke engines. Compression ratio is calculated by the formula swept volume plus clearance volume divided by the clearance value. And now looking into the calorific value, calorific value is nothing but it is a heat that is liberated by the combustion of a fuel. In this case, combustion of the fuel known as calorific value or the heat value of the fuel. Okay, it is expressed in kilocalories per kg, Okay, and for different fuels we have different range of calorific value, and it is highest in case of petrol, that is 11,100, and power kerosene it is around 10,850, and for high speed diesel oil it is 10,550, and in case of light diesel oil it is 10,300. Displacement value, it is nothing but it is the total surf volume of the all the pistons during the power stroke, and it is calculated by the formula Vd, that is a displacement volume, is equal to A capital L into N, whereas A is the piston area, L is a piston stroke, and capital N stands for, sorry, this should be a capital N. Okay, you can make note of changes. It is number of power strokes per minute of all cylinders. Now there is a simple problem, you can make a note. The question is to calculate the brake horsepower of the four cylinder, where internal combustion engine which has a cylinder bore of 14 centimeters, 16 centimeter stroke length, and 1100 rpm crankshaft speed. This I have mentioned. Now they have asked to calculate the bhp. So the formula for bhp is ihp minus fhp. Okay, already fhp is given, that is 30. So we need to find the IHP first. So IHP is given by BHP plus FHP. So directly we can find this BHP and FHP because we don't have FHP now. So let us consider the IHP first. IHP is found by the formula plane in general divided by 4500 into n by 2, and the data for this PLAN is mentioned. Okay, D, and we have to substitute this, we'll be getting the IHP. And after getting this particular IHP, already FHP is given, we can substitute, and by reshuffling the formula we can get the BHP is equal to IHP minus FHP, that is 96.4 minus the FHP which is given as 30 gives the 66.4, it is our BHP. And in the similar way I have given you one more problem, and you can solve this, and you can comment the answer in the comment section, where you are here to calculate the IHP, BHP as well as the compression ratio, step value, and all the formulas I have given in the previous slides. You can pivot the video and you can note the formulas. And already we have studied the external combustion engine and the internal combustion engine, and what I want to mention you again is the energy requirement. Okay, diesel engine develops more torque when it is heavily loaded, while petrol engine does not develop the torque. Means the torque generation is more in case of diesel engine when it is heavily loaded compared to the petrol engine. And under a single cropping system, if you are using any kind of engines, normally 1 HP for covering 2 hectares of land is sufficient. And if you are having more than one crop and you have adequate irrigation facilities are available, and you can go for 1.5 HP capacity of the engines. And other now the few note points for the exam point of view, these are the few things they have asked in the previous exams, I have noted here. For the power sprayer, minimum HP is 3 HP, and composition of biogas is methane, carbon dioxide, and the hydrogen sulfide. And please go on making note of these things. Okay, thermal efficiency of the diesel engine, I already mentioned in the difference, it is also asked in the previous exam. So I said that the thermal efficiency and the compression ratio and majorly differences are important, and you can make a note of this. And the firing order is also very important, you can make a note of. For the 4-stroke engine it is 1342. And the calorific value of LPG, I mentioned about the petrol and all, LPG was asked, it is 27,700. Okay, and in 2-stroke engines compression ratio is high or less, it is less, even that is asked. So I told you people to learn the difference between the 2-stroke and the 4-stroke engines clearly, and difference between the diesel engine and the petrol engine clearly. Who was the person who invented the internal combustion engine for the first time? Means it is our Nicholas Otto. And for the windmill, as I told, it is 0.5 HP is necessary, and latent heat of vaporization for water is 540 kilocalories. Okay, and high HP of an engine is always how much? Means it is generally more than BHP, that is brake force power, and it is high HP, that is indicated horsepower. So go through the definition once again if you could not recollect well, and you can answer this. Okay, this type of questions also will be asked in the exam. And the density of the granular metal can be determined by the instrument called pictometer. And next I mentioned about the Otto cycle and the diesel cycle. Now the question is, Otto cycle is related to which? It is with respect to the petrol engine, but we'll be not remembering the kerosene engine as well, right? You should make a note that kerosene engine also follows the Otto cycle. Here you should not get confused with the diesel engine or the diesel. Okay, that is different, and kerosene is different. And next, talking about the 1 HP of the engine indicates the power of the piston. Actually, the different options will be there, you will be clear there. And the useful life of the wheel type tractor is around 10 years. Okay, and the lowest temperature at which fuel ceases to flow in is known as pour point. This is also very important. What is pour point? It is the lowest temperature at which fuel will ceases to flow. And thermal efficiency of diesel engine varies from 32 to 38%. Okay, and at last we're at the end of the session, and from the AgriAddict team we have that particular mock test bundle known as Vijeta, and you people can purchase this and you can boost your preparation so that it will be helping you to score more marks in IBPS AFO mains exam. I wish all the best for who are preparing for the AFO mains now, and congratulations who have cleared the prelims exam, and wish you all the best. Thank you. And you can download this our AgriAddict app, and you can look into the various mock test available over there. Thank you.